Okay, let us discuss about the next topic, that is degree. What do you mean by degree? Degree. You hold a degree. That what degree you are having. When we talk about the college pass outs, what we ask them, what degree you possess? It means what is their qualification. And when we talk about the qualification means the highest qualification you are having. For example, being a BTech graduate, what is my highest qualification? That I am having degree, bachelor degree in technology. That is my degree. That is my qualification, highest qualification. Similarly, degree means the highest power of the variable in an algebraic expression. Highest power of the variable in an algebraic expression. Let me write an algebraic expression. 2x square plus y. Now, if you see clearly, what do you mean by power? Power means variable raised to power something. Here, power is 1, here power is 2. So, what is the degree of the given algebraic expression? It is 2. 2 is the degree of this algebraic expression. Why? Because 2 is the highest power. Clear? Now, basically, when we talk about this particular concept, we have one more concept. Again, I am giving you one more thing. Like 3y cube plus 2x. Now, tell me, here power is 1, here power is 3. What is the degree? 3 is the degree. Clear? Now, understand one more concept related to it. Very important concept. Now, just observe what I have written. 3x squared y plus 5a. Clear? Now, you might be thinking x square is x, it means x2 should be x square, 2 should be the degree. Yeah, because highest. But see, with this, we are having y also. And y power is also 1. In such cases, when two variables or three variables are simultaneously combined, then in that case, for that particular term, we add all the powers. For example, in this case, what we will do, we'll add 2 plus 1. So the total degree is 3. It means here total degree is 3, here total degree is 1. So what is the degree? Degree is the 3 is the degree. Again I am repeating. In such cases, when you have a combination of 1, 2 or more variables, in that case what will you do? You will add the powers of all the variables of one particular term, and the term with the highest power will be having that particular degree. Clear with this? Let us take one more example. 2 a, b, c, d, e, f, g, h plus 5 a, b, c, d. Now understand what is degree. How many variables? 1, 2, 3, 4, 5, 6, 7, 8. Every one is having power 1. So what is the degree? Total degree is 1 plus 1 plus 1 plus 1 plus 1. That is 8. Here how many variables? 4. Each is having 1. So 4. Which is the degree? So 8 is the degree of the given algebraic expression. Are we clear? Are we clear? Any doubt anyone is having with this concept? Degree of the polynomial. Next, coefficient. Next concept is coefficient. What do you mean by coefficient? Basically, we say coefficient of a variable. What do you mean by coefficient? First of all, if I segregate this word, I am having two words, co and efficient. What do you mean by efficient? He is very efficient in doing this. What do you mean by that? Skilled. Means expert. Means expert in that particular field. He is fabulous. He is having expertise in that particular field. This is what efficient means. Efficiency of that particular machine is higher than that particular machine. That is what efficiency means. Skill, the power, stamina to do. Similarly, efficiency coefficient. Co means before. It will be put before. Let us understand with a beautiful example. I have written x, I have written 5x, I have written 7x, I have written 11x. Can you see what is happening with x? Earlier, the power means 1. X was alone. There was no numerical thing with it. Earlier, x is multiplied with 5. Then multiplied with 7. Then multiplied with 11. What is happening? Power, the stamina of x is increasing. Earlier x was a no, now it has 5x, now earlier 7x, now 11x. What is happening? Its efficiency is increasing. And what is increasing its efficiency? These numbers. And these numbers are known as coefficients. And these numbers are known as coefficients. Why co? Because they are put before. And why they are coefficient? Because by putting them before, we are increasing the value, we are increasing the power of that variable. Hence they are known as coefficients. Are we clear? So number before any variable is known as the number before any variable is known as coefficient, also known as numerical factor. Do you remember? Another name is numerical factor. Clear? Okay, let us understand one more concept related to it. Now, clear with the coefficient, any number before, for example, if I written minus 5x, what is the coefficient? Minus 5. Even minus sign is there. Minus 5 is the coefficient. Any doubt anyone is having with this concept? Clear? So, next, one more concept related to it. Very important concept. Sometimes, I was talking about numerical coefficient. Basically, we have two types of coefficient. One is numerical coefficient, which is only a number. Sometimes we have literal coefficient, which includes variable plus number. Literal always means variable. Understand? Minus 2xy. I have an algebraic expression minus 2xy. If I ask you, what is the coefficient of y? The question is, what is the coefficient of y? Answer, you might be thinking, sir told us the number before. Leave y, whatever is left, that is the coefficient. So minus 2x is the coefficient of y. Similarly, if I ask you what is the coefficient of x, leave x, whatever is left, minus 2y, that is minus 2y is the coefficient of x. Any doubt anyone is having in this particular term? That's what we call them, coefficient and all. And if I ask you what is the literal coefficient of minus 2y, answer is x. Literal coefficient means only the variable. Literal coefficient, variable, which must include a variable. That is very important. Are we clear with this concept? So literal coefficient, numerical coefficient. Clear? Any doubt anyone is having in this? Next. Now let us study about the types of algebraic expressions on the basis of two basic important segregation. The two important segregations are on the basis of terms we segregate, and on the basis of degree we segregate algebraic expression. On the basis of terms, one term algebraic expressions are known as monomials. Algebraic expression having only one terms are known as monomials. For example, minus 2xy, minus 5x, 5. Even constants are also algebraic expressions, I'll tell you. Constants are algebraic expression. Constants are algebraic expressions. Why? Because if I write 5, there is no variable. What should be the rule? For algebraic expression, it is the combination of what? It is the combination of variable, constants and arithmetic operation. Now, variable is not there. I'll show you variable is there. If you cannot see the variable, I'll show you. Here variable is x or any other variable, but its power is 0. So variable is there. Anything raised to power 0, answer is 1. That is why constants are also algebraic expression. Do remember, very important. And you might be saying, sir, where is arithmetic operation? Plus 0. Algebraic expression. Though plus 0 is nothing, the same, but it's an algebraic expression as per the rule. Are we clear? So, one term, next two terms, known as binomials. How do we do binomials? Bi means 2, that is why 2 term. Nomial means terms. Do remember, nomial means term. Mono means 1. Binomial means 2. 2xy plus 5. Next, 3 terms. It is known as trinomial because tri means 3, nomial means term, 3 terms. 2a plus 3b plus c. 4 terms. Quadrinomial. Quadrinomial. 4 terms. Quadri means 4. Quadrinomial. 4 terms. 2a plus 3b plus c d minus e. Next, more than 4 terms is known as polynomials. Understand this important word, polynomial. I'll explain you polynomial in detail after this. Basically, polynomials, one or more terms provided variable power is not negative. That is very important condition. Polynomials, so polynomials basically provided variable power is not negative. For example, x plus y minus 1. This is not a polynomial because its power is minus 1. So polynomial is very important condition. Power cannot be negative. Clear with that? Next, on the basis of degree, if power is 1, power means 1 means linear. Power 1 means linear. Linear means 180. 180 means straight line. What is the angle made by straight line? 180. That is why they are known as linear algebraic expression. Power 2, we call them quadratic. Let me write an example. X plus y. It's a linear. Now in case of degrees, terms are not defined. Terms can be any number, but the highest power should be 1. Here also power is 1, here also power is 1. Clear? Next, power 2. X square plus y plus 3. It's a quadratic formula. It's a quadratic algebraic expression because highest power is 2. Here 1, here is no power. Clear with that? Next, power 3. Power 3 is known as cubic polynomial. It is known as cubic polynomial. Are we clear? Cubic polynomial means x cube plus y plus 5 plus z. It's an example of cubic polynomial because highest power is 3. Even this is also example of x, y, z plus 5. It is also example of cubic polynomial. Why? Because 1, 1, 1. What is the total degree? Total degree is 3. Hence, it's a cubic polynomial. We have to understand this. Next, power 4. Power 4 is known as biquadratic. Because quadratic means 2, 4 means 2 into 2, biquadratic. For example, x power 4 plus y. It's an example. Rest all the polynomials means all the algebraic expression. For example, if I have to write like this, what I'll be calling? I'll be calling algebraic expression with degree 5, algebraic expression with degree 7, algebraic expression with degree 4. Till 4 we are having names. Linear 1, quadratic 2, power 3, that is cubic, power 4, biquadratic. After 4 we'll be calling them how? Algebraic expression with degree 5, algebraic expression with degree 7, algebraic expression with degree 8. Like this we call out. Are we clear with the concept of degree and the segregation of algebraic expression on the basis of terms and degree? Any doubt anyone is having with this concept? Next we are having like and unlike terms, which is the last concept for exercise 12.1. After that, 12.1 exercise is very easy to do. So basically, like and unlike terms. We'll be discussing like and unlike terms. Next concept, like terms. Now, earlier we discussed about like terms. When we talk about integers or when we talk about fractions or rational numbers, we talk about like terms whose denominators are same. So we talk about whose denominators are same. But when we talk about algebraic expression, The two prominent conditions are, for terms to be like, they must have same variables. Very important concept is variables must be same variables. Next, variables must have same power. Variables must have same power. That is also a very important concept. If these two concepts or if these two conditions are fulfilled, the terms are said to be like terms. The terms are said to be like terms. We call them like terms. Now understand. I am writing the example. X square y minus 5 yx square. Understand. Are they like terms or not? Let's see. First of all, same variables. xy, yx. Same variable. Variables must have same power. What is the power of x2? What is the power of y1? What is the power of y1? What is the power of x2? Hence, they are like terms. We cannot deny they are not like terms. They are like terms because same variables and variables must have same power. You might be thinking, sir, but we have written x square first and y here and y first here and x square. See, if I talk about multiplication, multiplication is always commutative. I hope you know that. A into B is B into A. Similarly, x square into y or y into x square, both are same. They are multiplying here right now. If no sign is there, it means multiplication. They are multiplying with each other. Clear? Next thing. Next thing is x cube y cube x. Now tell me, are they like terms? You might be thinking, sir, yes, because same variable x and y. Same power, variable must have same power, 3, 3, 1, 1. No. Variable must have same power. It means here, what is the power of x? It is 3. But here, what is the power of x? 1. Hence, they are not like terms, they are unlike terms. Are we clear with the concept of like and unlike terms? Like terms and unlike terms. Clear with this? Any doubt anyone is having? Let's move on to immediately exercise 12.1. We'll do few questions related to it. First of all, we'll do question. Let's do first of all question number 5. Classify into monomials, binomials and trinomials. Classify on the basis of binomials, trinomials and trinomials. Okay. First one, how many terms are there? 2 terms are there. So what is that? Binomial. So let's observe. First one, it's binomial. Second, question number 5 I am doing. Question number 5. Classification. Let's observe. 4y minus 7z. It is binomial. Why? Because 2 terms are there. 2 terms are there. Because one sign is there, 2 terms are there. Y square, monomial. Because no other term is there, only one term is there. Third, trinomial. Fourth, monomial, because constants are monomial. Then trinomial, binomial, binomial. 8th, monomial. 9th, trinomial. 10th, binomial. 11th, binomial. And 12th is trinomial. Now I have a question for you. For example, I have written x plus 2y plus 5x. What do you think? It's trinomial because 3 terms are there. X, 2x and 5x. You might be thinking, but see, x and x are like terms. Yes or no? So we can add 1 plus 5, it is 6x. 6x plus 2y. So hence, though the algebraic expression seem to be trinomial, but because of like terms, it converted into binomial. This is also important thing. You have to be careful. Even the questioner, your teacher, can confuse you, can check your knowledge based on this also. This is important concept. So if you are having like terms, first of all merge those terms, then only you are able to do. Clear? Next, question number 6. State whether a given pair of terms is of like terms or unlike terms. Like terms or unlike terms. Let's see. 1 and 100, yes, they would be, because constants are like term, no degree is there, no power is there, no variable is there. So 1 and 100, yes, they are like terms. Do remember all constants are like terms. Next, minus 7x, 5 by 2x. Yes, they are like term. What is the variable? Xx. Power is 1, power is 1. Yes, like terms. We need not to check the coefficients. Do remember? Coefficient can be different. It may vary. Only the thing is, variable and their power must be same. Third one, it is minus 29s minus 29y. Now you might be thinking they are like this, minus 29. No, coefficient again, we need not to worry about the coefficient. Leave it. When we talk about like and unlike terms, leave the concept of coefficient. Concentrate on variables and their power. X, here y, unlike terms. Next, fourth, 14xy, 42yx. xy, xy, x power 1, x power 1, y power 1, y power 1, yes, like terms. When no power is given, I hope you know that, I have discussed in exponent powers also. When no power is given, it's always 1. Fifth, it's 4n square p, 4np square. Yes, now see. N square, np, np, but n square, n power 1, p power 1, p power 2, unlike terms. I hope you can do it, rest of the questions. Clear? Question number 7. Identify the like terms in the following. You can do this question, it's very easy. Identify like terms. I'm doing one part, I'm doing a part, and first of all I'm writing the question. It is minus xy square minus 4yx square 8x square 2xy square 7y minus 11x square minus 100x minus 11yx 20x square y minus 6x square y 2x and 3x. Let's understand the question. We have to identify like terms. Xy square. Xy square. Do you see any other x? Yes, like terms. Any other x square? Xy square? No. So minus xy square and 2xy square, one term, like terms. Next, xy square, yx square. Yes. Minus 4yx square, 20x square y. So minus 4yx square and 20x square y. Next, 8x square, x square. Do we have any other term? X square. Yes, x square. 8x square minus 11x square minus 6x square. They are like terms. Next, y term. 7y. Do we have another term? Yes, y. 7y and y, one term. Next, done. This is also. Next is term of 100. Minus 100x. Do we have any other term including only x? Yes. 3x, done. Next, minus 11xy. Minus 11xy. Do we have another term of xy? Yes. 2xy. This is how we have to do. So pairing 1, 2, pairing was done. Clear? Are we clear with the question how to do? Next concept. Question number. I'll do only one part. Rest of the part will be doing yourself. Let me do. I am going to do question number 3. Identify numerical coefficient of the term